On to the normal force. The typical force. No, not the typical force. Any surface that an object touches exerts a force called a normal force. Remember, in physics, we use the word normal to represent perpendicular. Did you notice that the object has to touch a surface to feel a normal force? That means the normal force is a contact force. Normal is a math word meaning perpendicular. The force is called a normal force because the normal force is applied in a perpendicular direction to the surface, away from the surface. Again, going back to the phone and the eraser, the normal force is going to be up in this direction, perpendicular, pushing away. Since the normal force points away from the surface, the normal force is a push force. The job of the normal force is to prevent the object from breaking through the surface. So what that means is without the normal force, this would go right through. There has to be some sort of push back on this. We know the force of weight pushing down. The force of Earth acting on this eraser is pushing down. Meanwhile, the force of the phone pushing up on the eraser is opposing. That's my script action. Seeing who I'm talking to, no doubt. If an object is going to be connected to a rope or string, then the string has to be taut, and the object is going to experience a tension force. The direction of the tension force is the same as the direction the rope points away from the object. Agent of the tension force is not the rope itself, but rather the object and the other end of the rope is attached to. Since tension force attracts the object towards the agent, it's a pull force. The job of the tension force is to prevent the rope from breaking. Tension is only exerted if the rope is taut or straight. So to see what a taut rope would look like, I have this. Not taut, taut. Not taut, taut. Should I keep going? If the rope is slack, then no tension is exerted. Because tension requires an object to touch rope, tension's a contact force. Friction, the big one, the scary one. So many students, no need to, it's just another force. Friction is a force that acts between an object and a surface. The purpose of friction is to prevent sliding between the object and the surface. Note that an object must touch a surface to experience friction. This makes friction a contact force. Normal force always acts perpendicular to a surface, but friction will always act parallel to the surface. So when I take this and I put it on my phone, we've got the normal force. We also have a frictional force going in this way. Well, there's not anything pushing in this way, so it's not going to move, or it should move. So as I tilt this, friction is keeping it up the ramp, so it is parallel. Misconception says friction opposes motion. So if an object is moving to the right, then friction must be directed to the left. Wrong. Mr. Wright says friction doesn't oppose motion. Friction opposes sliding. Sometimes that means friction's direction is opposite of that motion, but sometimes that means that friction helps motion. And that is so much better put. I'm guilty of phrasing it like this because it simplifies things for you. But as we move on into things moving in a circle or two dimensions, friction doesn't necessarily oppose motion. It's, in fact, going to help maintain a circle in a lot of instances. Let's say we have an experiment where a rubber block slides across the metal surface. What the heck happened to my shirt? The gray line. Meanwhile, the same rubber block is given the same initial velocity across an ice surface, the blue line. As you would expect, the one on the ice is going to slide a lot further than the one on the metal. And that's because there's more friction between rubber and metal than rubber and ice. This means that the top of the rubber block changes its motion more rapidly than the bottom of the block. So think about that for a second. The top changes its motion more rapidly than the bottom block. The bottom block has this friction that's slowing it down and resisting some of that forward motion. But don't forget,